He went to the restroom. Okay, this is section 2.8. This is the last section of the chapter.
So chapter tested.
So there'll be a quiz tomorrow over the last few sections that we've had. Monday, we'll go through the review, which I'll hand out tomorrow, so you have the weekend to work on it. It'll be due Monday morning. And Tuesday will be your chapter 2 test.
I don't remember.
Those of you not talking, did you all hear what I just said? That's what I thought. Or talking, yeah. Okay, so I'll say it again. Tomorrow is a quiz over the sections since we've had the last quiz, 5 through 8. Monday we'll be going through the review. I'll hand the review out tomorrow, and you'll have the weekend to do it, so it'll be due at the beginning of the period Monday. And then Tuesday will be the test over this chapter. Okay? All right, yes?
For the quiz tomorrow, what CK12s do we have to do?
5 through 8.
Okay, and then for 5, I can only get into
Yeah, just do 2 of them.
Okay.
Yeah, B and C are the only 2 that are opening in 5, so those are the only 2 you have to do for extra credit. The last quiz, there was only one person who actually did all the CK12s. So those of you that are disappointed with your grades, just remember you could have added another 10% on if you had done your extra credit. So if you're choosing not to do your extra credit, I don't have a lot of sympathy when you aren't happy with your scores. I'm just saying. Okay. 2.8, scatter plots. Why don't everybody turn your computers around or something, because everybody's looking on their computers and I'm trying to talk and I don't feel like I'm being paid attention to. And that makes me sad.
I get sad all the time.
Yeah, it is.
We should
Tears.
talk about it together.
Okay. So, 2.8, scatter plots. This is the next real world, the last chapter we had word problems. Everybody hates them. But that's why you learn math, is so you can actually do real world problems. Scatter plots. I'll give you a little side story here. Kate is in her freshman year in college, and she's got chemistry this semester. And she's got a chemistry lab. She was telling me about it last night. And there's a lab coming up next week. She said the average usually in this lab is 20%, and you can't drop it. So she's trying really hard to prepare herself so she can do better than the average. And she was explaining to me the lab, and it's an iron lab, and they're going to be introducing different volumes of an iron solution, and at the end of the lab, basically, they have to figure out the concentration of iron that they were given as a sample to them. And as a part of the lab, they have to take all their data, and they have to create a scatter plot, and they have to use a linear regression, which is what we're going to learn today, and get an equation, and then be able to prove that that equation actually shows what the amount of iron is that's in their sample. So she was trying to review how to use the calculator to do scatter plots and linear regression, and that's what we're doing today. So it definitely has a real-world application. Whether you're going to be a chemist or not, I don't know. But some of you, depending on what career you want to go into, are going to have to take chemistry. And being able to, and chemists and researchers use linear regression all the time. And the reason is, in real life, most data that you collect is not going to be a perfect line. It's just not. I mean, we're used to seeing these perfect lines, but in the real world, perfect lines don't happen. Data doesn't form a perfect line. And many times the data might form a parabola, or it might form a quartic, or a different kind of function other than a line. Okay? And so as you get into more math, you're going to learn how to take data that someone has and actually put it into a computer or a calculator and figure out what we call the line of best fit, or the function of best fit. Today we're doing lines. So the purpose of learning about lines is actually to apply it to real life, and real life isn't straight lines. So we have to be used to seeing graphs with scatter plots and be able to make sense of them. If I'm just thinking of an example, and this is going to be an exponential function, but all of a sudden we have an outbreak of Ebola in the United States. CDC, the people who work at the CDC are very strong in math, okay, and data collection, because as soon as they hear there's an outbreak, they have to be able to perform some calculations and figure out every minute, every hour, what the potential is for that spreading to more and more people, and how fast we've got to contain it. And they use not linear, they'll use exponential growth models doing the same kind of thing. They're going to have to take some data, they're going to have to put it to an actual function, figure out what an equation of that function might be, so they can make projections about data they don't even have. a lot of times you collect this data and you've got to use that data to make future decisions or future projections, and you've got to be able to do line of best fit like we are. Okay, so this is why we learn it, is because this is actually in the chapter the thing that actually has real world applications in your life, or could. All right, whether it affects you because you're doing this career or it affects you because you don't want to get Ebola, this is why people use the strategy that we're going to talk about. Okay, so when we look at, let me get into it. This section, the very first page, discusses a couple of things, which is, first off, is correlation. And correlation is just, in my idea, a fancy word of a slope. Okay, if it has a positive slope, which if I kind of do a line of best fit through all these points and get a straight line, it goes up from left to right. So that's a positive slope. We call that a positive correlation when we're talking about data. Okay, a negative slope, negative correlation. All right, and you can just see it based on just looking at the points. This is going to have no correlation. I really can't figure out what line of best fit I could draw through all of this that would really represent this data. So there's no correlation. Okay, as you get further into statistics, which we aren't covering in this class, but your calculator will actually tell you the certainty that your equation is correlated to the data. So you're usually looking for a higher percentage certainty that whatever line you find is closely correlated to the data. And that's why we use the word correlation. Okay? When we're trying to create a scatter plot by hand, okay, you're going to learn how to do them by hand in this section. You're also going to learn how to do them on a calculator. Okay, when we're trying to create them by hand, what I like to do is kind of draw an oval around all the points, trying to get all the points in your oval, and then pick the ends of the oval to connect with a straight line. It's sometimes difficult to take a ruler and try and figure out the best straight line here, so I just draw like an oval and then connect the ends of my oval and then make that a straight line. These points don't have to be on your line. That's something that students sometimes don't understand, is the points that you're given, just because they're in your data set doesn't mean when you draw your line of best fit that they have to be on your line. In fact, I could draw a line of best fit through all of these and maybe none of them are on the line. That's okay. I'm just trying to approximate how to make this a linear equation or an equation of a line that I could then use to predict what potentially could happen in the future. Does this look like a positive or negative correlation here? Negative. And so once I get the equation of the line, this is in 2009, based on the trend that I see, I can find the equation of the line and I can say in 2019, this is where I expect the data point to be, based on my line that I found. Okay, that's the point of this whole process, is to make predictions in the future. Okay? So what I thought I would do is maybe do a line of best fit manually, and then I'm going to have everybody get a calculator, and I'm going to talk you through how to use a calculator to do a line of best fit with a calculator. Okay? Let me see if I can do a quick problem here.
Now I understand my question.
Okay, I'm going to just use this data here.
Compared to the volleyball players that are playing in the first team, because that girl,
Okay, this is the data. The problem is, this is the age measured in months and sleep measured in hours. Of what? Does it give me information? Well, I'll just do a graph real quick. Okay, so first off, when you're graphing these by hand, you need to identify what the scale should be. And the scale just means every tick mark in the x direction, what do I want it to represent? 1, 10, 5, something where I can kind of fit all of this data and I can graph it kind of easily.
Can't you start at like 15? Or,
Well, I'm going to start at 1.
oh, never mind.
I'm doing the x.
Go by 30.
1. I might do 5s. 5, 10, 15, 20, 25, 30, 35, 40. So that will kind of give me something that I could fit in my viewing window.
Just asking questions.
Okay? And then what do you think? I'm going to go ahead and start at 0. Well, let's go by,
Fours.
well, we could even start, maybe we could start at 12 or 10.
Breaking the line.
And then, yeah, just put a line break in there just so we can kind of get the window of what these points look like. Because I don't want to go by 5s if I've got 13.75 and 13.5 and 13. It's going to be hard for me to graph those.
Yeah, go by 1.
So let's just start here at 12 and realize there's going to be a break in the graph. Okay. Or I could just go up to 12 and then graph them all, but we'll just start here. Okay. 16 is going to be 13, 14, 15, 16, and 1. No, 1 is not there. 1 is right here, right? Because each one's 5.
Yeah, you're right. You're right.
15.
Are the top numbers the Y or the X? Okay.
It's probably
315. 315. I'm going to go down. 6, 14.25. So 6 is going to be a little greater than 5. 14.25.
big jump.
9, 14. So 5, 10. So it's a little shorter than this, and it's at 14. 12, 13.75. 5, 10. So 12 is going to be kind of in the middle. 13.75 will be here. 18 is going to be after 15. 13 and a half. 24, 5, 10, 15, 20. There's 25, so it'll be just shy of 25 and 13. And then 36, that was 25, 30, 35, so a little more than 36, or 35 and 12. Okay.
It's a negative correlation.
Yep, negative correlation, definitely. So what I'm going to do,
What I'm thinking.
is just draw this line, an oval around my points, and I'm just going to pick a point here and a point here. I'm just going to draw a line from end to end. And call this my line of best fit.
You only need 1 point.
I just need 2 points
2 points.
to make a line manually. And my line's not very straight. I should have used a ruler. My oval, it's all right. But I'm just going to call it my line of best fit. So now I'm going to talk you through how to find the equation of this line, because that's what I'm really after. I'm after the equation of this line, because if I know the equation, I can then plug in a number way down here that I don't have any data on and predict or project what I would expect to happen with that point plugged in. So I'm trying to find the equation of this line. Okay, so to do this, what I need to do is I'm going to just look at my line and see if any 2 points on this line actually go through an integer coordinate point. Okay, so I'm going to say maybe this one,
And the one that's diagonal.
that one,
Yeah.
not quite. Maybe this one might be the closest here.
Oh, wait.
Okay, notice I'm not picking 2 points that were given to me in the data set. I'm picking 2 points on the line I just created.
Oh,
I found one that works.
okay.
Okay, because I want to find 2 points on my line, not 2 points from the data set. Okay, so now I'm going to figure out what these 2 points might be. So 5, I'm going to call this point 10, and this was 12, 13, 14, 15. And I'm going to call this point 30, where's my other point? Right here. 5, 10, 15, 20, 25, and 13. So I just found 2 points on my line, not 2 points of the data set. Now, don't we all know how to find the equation of a line if given 2 points?
X2 minus, oh, wait, no,
Find the
Y2
slope
minus
first.
Y1. And then X2 minus
13 minus 15, 25 minus 10. So the slope is 2/15. Does that make sense?
Wait, 215. Oh, yeah.
Wait, wouldn't it be negative?
This is here. Yes. Negative 2/15. And then that's a good catch. If I get a positive number and I've got negative correlation, I did something wrong. So always check your answer as you go and ask yourself if it makes sense. Okay? So now I know y equals mx plus b. So I have y equals negative 2/15 x plus b. I'm just going to pick one of these 2 points and plug it in. So I'll do 10, 15. Okay. 10 over 15
2015.
is 2 over 3. 10 over 15. I'm simplifying first. Did you see that? This is 10 over 1. 10 over 15 is 2 over 3. So that's negative 4/3.
Yeah, I can't.
Now I can multiply everything by 3.
Yeah, that's
And then add 4.
49 divided by 3.
Yep, you're going to get wacky numbers when you do this. Okay, so now I know the equation of my line.
So B.
Do you all know how to do this already? Well, I know, but I mean, if I'm not getting paid attention to, and you guys don't do well on a test, there's a correlation there. There's a correlation. Okay? I just came up with this equation as my line of best fit. Is it going to be perfect? No, because I didn't use a calculator. So, to figure out what it should be, everybody go grab a calculator. And get a different one.
What? It is not going
I probably just need to put batteries in it.
Mine work.
Does it graph? I don't know
It
either.
has math, move, data, and all that.
we're gonna be out like
Does it have
5 hours.
like a y equals button for graphing? You might just go grab one of mine just so you have it. Okay. So in the textbook, there were step-by-step instructions on how to do this. So if you don't understand after we go through it, refer back to your textbook as you're doing problems on WebWork, because it gives you step-by-step instructions. Okay? Turn your calculator on, and you're going to go to Stat. And I'm not sure why I'm using this one, because you just gave it to me as dead. Does everybody see the Stat button? Stat. Okay, and you're going to go to Edit, and you see lists there. Mine says L1, L2, L3. Everybody might have something different.
Yo, me did this.
L1, L2, L3. You're going to go to the top, like L1, and just hit Clear, Enter, and it clears the whole list for you.
Wait, okay.
Oh. Oh.
Oh, clear, CLR list.
You go to L1, so arrow up so that it's L1 is, no, first you hit Edit, and now you have these. Go to L1, and Clear, and Enter. That will enter everything, or clear everything. Okay, so here is L1, here is L2. So type these numbers in. After each number, just hit 1, or enter, I mean. 1, enter, 3, yep.
Okay, so enter what?
And then do the same thing for this.
So for 2.8, can we use the calculator
Uh-huh.
only?
Uh-huh.
14.25 is this.
I don't know how to use your calculator, so I can't help you.
Do we have the computer?
No, he has his own.
He's one of those guys. Brings a calculator now.
Anybody still entering data?
Well, my list already, it's something that's next to this.
Your
I don't even know how to put it.
Can you add a number?
You're under L1,
Yeah, under L1.
so you just enter 1, enter 3, enter 6, enter.
Okay.
I don't know. I lost my other list. No, there's another button pressed.
Were we supposed to put the like 13s in front of that and everything?
Uh-huh. The numbers just as they're written. L1 is this list. L2 is this list.
Okay. So is like L1 always the top list?
Or does
Yeah.
it actually?
Okay.
L1 is X.
L1's usually X and L2 is Y.
Does it change it if we do it differently?
Uh-huh.
I feel like it would.
It does?
Uh-huh.
Oh, I didn't know.
Well, it will, depending on how you've got your plot, bringing the data in, which I'll show you next.
And L2 too.
Make a note on what your lists are called, because there's some calculators that start at L4. I don't know why, but just make sure you know L1 is your first, is your X, and L2 is your Y. Anybody still entering numbers?
I'm doing last one. There. I did it.
Okay, once your numbers are in, you're going to go to the Y equals button, which is the top left button, very, very top left button. You're going to go up to plot 1, enter.
Plot one.
Plot 1.
Is it like above?
Yeah, it's,
Doesn't do anything.
okay, hold on. I got to figure something out here.
Did you go to Y equals?
I'm going to go to,
Oh, there it is.
Oh, maybe we're supposed to do
so yeah, do second and then stat plot first.
Wait,
I'm sorry, what?
Oh.
Second, the blue button, and Y equals. Second, Y equals.
And then what,
And then
what do we
plot
do?
one.
Okay, plot 1 should say on. If it doesn't, toggle over to the word on or off and hit enter, and it should toggle to on.
how do you go back if you just click the Y equals?
Just do second Y equals. Okay, your plot 1 should say on. Okay, if you hit enter on the plot 1, it'll ask for type. The one that's highlighted for me is the first, which is just a scatter plot, which is fine.
I can change the periods. That's cool.
X list and Y list. So if you put your X column in, and L1 is what you used, and then L1 should be what's written there. And then L2 for your Y list. Yes.
You should come sit by us, Kyle, so we can help you. I'm sitting right.
You just hit enter,
That's true.
and then you just hit on. See how it's highlighting on? Now it's on.
So once I do that, what do I do?
Okay, everything's set the way everybody likes it.
Wait,
Oh,
what
we
did
had to do it
I have L1
last.
and L2 on.
Yeah, make sure it's on, and then make sure your list identified for X and Y match your list in your
Wait,
stat.
do you want me to turn off L2?
Sure.
Oh, okay.
Yeah, make sure everything else is off. Okay. Make sure mine's on. And now we're going to make sure all of the other things when you hit Y equals, make sure you don't have any other equations in there.
So it's supposed to wait.
So just hit clear if you've got any equations in there.
Oh, I just hit clear.
That's fine.
Oh, wait.
If you go to Y equals,
So do we clear?
yeah, if L1 and L2 are what you had for your list. Everybody go into Y equals and then hit clear for any equations that are already in there. Y equals. Y equals clear. And then just, let's see here. And then go to graph and just click graph.
Where's that?
I just get a voice. Oh, okay.
Yeah, mine just has the graph.
Just has the axes, right?
Yeah.
Okay, so what we need to do here is, let me pull up.
Points? Let me see what
It's like on the last page, I think.
Here are all the instructions. And if it says, if nothing shows up, press zoom and scroll down to 9. Zoom, it's the middle, scroll down to 9. Hit enter,
Hey. Okay.
and when you hit enter, the points should show up.
That looks like.
Mine just showed up, but it's like.
Yeah, that's what I just said. You go to zoom, and then scroll down to 9. You should just see a screen with points. I don't know. It depends on what you entered.
I redid it like I should off. It was
Such an
all I should.
awkward conversation starter.
That's just so cute. Bells are cute. I wouldn't.
Just saying, dog, but it's so cute that kind of.
Make sure. Yeah, you've got, I don't know what these 2 points are. There should, yeah, I know they are, but there should be exactly the same number L1 points as there are L2. So you've missed, well, I don't know what you mistyped. You have to go back through the points, I'll pull them up again, and figure out which ones you messed up with. Did you get yours up?
It has a point.
So did you go to Zoom and then go down to 9 like I asked? Yeah. Enter. And I don't know what these points are, so you've done something with your list.
Might change.
So I don't know why you have 1.3, 2.2, 5.8. Okay, so if you don't have this up, and just to save time, find someone that and pair up with them that's already got it, because I don't want to waste any more time
I definitely
fixing.
will forget how to do this.
Okay,
I'm glad it's online.
so now you see points that are similar to what I graphed. Pretty similar. Okay, so now if you follow the instructions, which I'll pull them back up, now you can find the equation of best fit for the data. Here are the directions. After completing steps 1 through 5, which we've finished, press stat, then arrow over to calc. Now, don't click anything. Go down where it says 4, linear regression, LINREG. And it tells you it's the AX plus B, so that's the form, which is what we know is the slope-intercept form. Okay. Press enter, and then you'll be taken to a screen, and down at the bottom it says calculate. No? Yep, so you've got yours already. So just hold on to that. Everybody should have the equation where A is equal to negative 0.96435 and so on, and B is 15.25. Did everybody get that? So scroll down to calculate
I swear we are.
and hit enter.
Oh, I forgot to hit it again.
Go down to calculate. Yep.
Yay.
Did you figure it out, Gideon?
It's like Portal.
You go to stat, type everything in.
Yeah, I
Go to calc, go down to linear regression, go down to calculate,
It's like Portal.
and I don't know why.
You're talking about something else. I'm like,
I wonder if you've got the wrong list in your,
Get your mind out of this.
so
I
stat.
couldn't find L1. It started on L2.
Okay, so we need to go, the list is, it started on L2.
Get your mind out of the Grand Canyon.
this is wet,
Thank you.
not what.
So you put L2 here and L3 there? Is that what you did, or it starts on L1?
Well, that's just where it was.
I know, but what is yours in?
L2. X is on L2 where Y is on L2.
Technically, there is.
L3? Okay, so it's like this?
Okay, divide it laterally.
So I don't know why it's not. Let me go to stat here.
I got in no.
L2, L3.
Could just like. put in-
Well, share with, have you got yours up? Did yours?
It
We
didn't.
could just cut the room in half like.
Stat,
That's
calc,
not how you cut something in.
linear
So
regression,
we have to do like that.
and yours is L2. Yeah, absolutely, could
And then
be.
if it shows up
I don't know why. If you have, well, you can
Well, you could cut it
sit
like
with
that, but equal
Nicole,
half.
so I want to keep going with this.
Split in half.
Okay. And Thomas, do you have yours up?
There's a little. Uneven geometry.
You have your equation?
Triangles over.
I'm not finished yet with what I'm doing, so go ahead and,
I have it on.
Okay.
Yeah, that's, yeah. Triangles are the best.
What?
okay, those of you who are still with me, when you see this equation, A is negative 0.96435, negative, and then B is 15.25, approximately.
You want us to go on the.
Just a few. On WebWork, you go to as many as you can.
Okay, it wants like all of it.
So there's the equation. So let's compare that with the one that I had. What's 2 divided by 15? 0.133. And then what is 49 divided by 3? Is 16.3.
So is that
Okay?
good or?
Yeah, it's not bad. I mean, for an approximation.
It's guessing and then like.
Yeah, I mean, I didn't have a straight line, and I didn't have a perfect oval, and I mean, you're not going to get, there's going to be a problem on the quiz or the test that you have to do manually. Okay, and everybody's going to get a different answer, and that's okay.
Oh, that just clicked in now.
Yep, I'm not looking for exact, I'm just looking for your process, and that you got somewhere close.
So don't write on.
So I would count this answer as okay, if that were the problem I was doing on a quiz. Even though it's not perfect, you went through the right process to get there. Okay? So make sure that you know how to do it manually, as well as using a graphing calculator. Okay? All right, I'm recording this, so you can come back and watch it if you're lost. And
This is on 2.8.
this is 2.8. And remember, there's a page in the textbook that walks you through step by step how to use the calculator.
Oh,